Good morning, everyone. We'll wait for 2 more minutes. Let all your friends join up, okay? Right, ma. So, fifth unit has been started with the transients, right? So now you're aware of RL transients charging, right? RL transients charging, it was derived in the last class, and I of t value has been obtained as this. I of t is equal to I into 1 minus e power minus r by L t. So here you have the time constant, okay? So time constant in RL, it has been defined as the ratio of L by R. So this is the time constant which has been derived for RL transients charging. So next we will move on to RL transients discharging. So RL transients discharging, you also call it as decaying. Okay. So the meaning of this is the circuit has been connected. This is the circuit for RL decay in transients. So the switch was in position 1. This is the switch which is in between the position 1 and 2, right? So this switch has been connected in position 1 for some time, and after some time it has been changed from position 1 to position 2. Okay, so during position 1 the inductance would have got charged. Okay, and when it has been changed from position 1 to position 2, now it has been marked with position 2, right? So now we go in for decaying transients. Decaying is nothing but the discharging transients. Okay, now in discharging transients, the inductance which is connected here and which is charged completely in the first position will be decaying or will be discharging in the next stage. Okay, so same way we will be writing a equation based on KVL. So this is the circuit now under consideration. Okay. This is the circuit under consideration. Okay. So you have a resistance and an inductance and no voltage sources there. So you will write the equation now. R into I is the current flowing through it. Okay. R into I plus L into di by dt. Okay. 1 minute. right? Ri plus L di by dt is equal to 0. Now, we will take Laplace transformation. See, always this is the procedure, right? The equation for KVL based on KVL, take Laplace transform. After solving it, we will go in for inverse Laplace transform to find out the final current value. Okay. Now, taking Laplace transform, R into I will become R into I of S, okay, plus L into, for di by dt you have to write. So for di by dt, I will put it as S into I of S, okay, yes, because d by dt, right, minus I of 0 plus. So inductor capacitor will always have an initial charge, right? So we will write it as I of 0 plus. We are subtracting this because we need only that circuit output. Okay, the previous charges which has been stored is not required. So what we do, we subtract the excess charges. Okay, so now, when I'm writing this is I of 0 plus, I have to mention what is I of 0 plus. I of 0 plus is nothing but the current which was circulated through the inductance at position 1. Now, what is position 1? Position 1, the switch is connected here, right? So, you will just write it as E by R. E by R is nothing but the voltage by resistance. The normal current we write, right? Voltage is equal to current into resistance. So same way it has been written E by R. Okay. Now substitute this value I of 0 plus here. Now substituting this, you will have it as R into I of S plus LS I of S minus, substituting this value, you will write it as LE by R is equal to 0. Clear? Now, pulling out the like terms together, I of S has been pulled out into R plus SL, okay, is equal to LE by R. Just rearranging the equation. Now, what is E by R? E by R is equal to I. So, you will have it as LI, okay. Now, we wanted the value for current I of S, right? So, rearrange this L into I by R plus SL, okay. Or this can be written as, this L is brought down, okay, because the coefficient of current should be removed. Then only it is simple when we take Laplace transform, right? So you will write it as R by L plus S, okay. Now just look at this equation. This equation is of the form 1 by S plus A, okay. So taking inverse Laplace, you write it as e power minus RT by L, okay. And this I remains the same as like this, okay. Now simplifying this I of t, we write it here as I of t dash just to show the difference between the charging and discharging. Charging, we have taken it as I of t. So here we are taking it as I of t dash, okay. I into e power minus t by tau. What is tau? We know what is tau. Tau is going to be the time constant R by L, okay. Now the thing to be noted here is, here it is discharging. So if I plot a graph between the current and time, okay, between the current and time, the graph will be discharging, okay. How to obtain this is, have various values for t, okay. Various values of t means you will have first t is equal to, small t is equal to capital T, okay, capital T, I mean the time constant. Second, small t is equal to 2 times the time constant. Third, time is equal to 3 times the time constant, like that. So what will happen? The time constant will get cancelled and it will be e power minus 1, e power minus 2, e power minus 3. So you can put it in your calculator, get the values, right? So when you get the values, try to plot the graph, it will be decreasing like this, okay? I hope you would have understood. Put the value of t, see here, put the value of t, t is equal to capital T or tau, capital T or tau. Next, put t is equal to 2t, okay. The capital T, what I'm telling here is the time constant, okay. And again put small t is equal to 3 into t, like this. If you put, if you keep on put, what will happen, this t, the denominator t will get cancelled with the numerator t. So you will have first chance, you will have e is equal to, I of t is equal to I into e power minus 1, okay. Then e power minus 2, e power minus 3. So when you put the value in your calculator, you will have some numerical values, right? The numerical values can be written like this. Okay, 1 minute. So this is the graph for RL discharging. Okay, this is the thing you have to definitely note. RL charging. See, RL charging, the equation is what? I of t is equal to I of t is equal to I into e power. I is equal to I into 1 minus e power minus t by tau. This is for charging. Okay. Now for discharge, and the graph will be in the, see, this is the graph for charging. It will be increasing, right? I versus t is the response graph. Okay. It will be increasing. But in discharging, if you see, the equation is I into e power minus t by tau. Okay. And the graph, if you see, the graph here it is 1 minus, in charging it is 1 minus, and in discharging it will be direct, the 1 minus will not be present, it will be directly I into e power minus t by tau. This is for discharging, and the graph, it will be decreasing. This is the difference between charging and discharging. Okay, now same way you can calculate the values of voltage across resistance. Okay, voltage across resistance, you know, R into I. Now I we had calculated, just multiply it, you will get the resistance value. And from the circuit we can write, see, from this circuit you can write, this is the circuit under consideration, the voltage across resistor plus the voltage across inductor will be equal to 0, right? So you will write it as ER plus EL is equal to 0, this equation. Okay. Now, you know resistance value, ER value, you know, just rearranging, you can write EL value. EL is equal to minus E into e power minus t by tau. Okay. Now, when you draw a graph for the same way, drawing the graph means that taking some values for small t. You put small t value as equal to time constant value. Second, put small t value as equal to 2t. Put third, you put small t value as equal to 3t. So you will get different values of E, right? So plotting, you will get the graph as for resistance, it will be charging, it will be discharging in the positive side, and for inductance it will be on the negative side, because if you see the equation, you have here a minus C, okay, but here you have a plus C. This is the difference. Okay, I hope this is clear, right? We will now go to a problem. No problem. See, a DC voltage, see, uh, the transients problem will be similar to the derivation, whatever we have done. Okay. If the circuit, what has been given in the question is same as that of the derivation, you can directly take the final formula and apply it. Okay. But if the circuit is different as that of the derivation, then you have to derive completely. The procedure will be as we have done in the derivation. You have to write equation for KVL, take Laplace, okay, solve by partial fractions, then take inverse Laplace, find out the current value. Okay, this is the procedure. Now check here, this is a simple question. A DC voltage of 100 volts is applied to a series RL circuit with R is equal to 25 ohms. Okay, now they are given, one second. Now they are given it is going to be an RL circuit. R is 25. Okay. And R is 25 and DC voltage is 100 volts. Okay. This has been given. Now, what you have to do, what will be the current in the circuit at twice the time constant. So the twice the time constant value, they had given it. Okay. So what you will do, now you can directly see this circuit means that as whatever you have done in the charging, it means the same, right? They have not given the position of the resistor, they have not given any circuit. So directly you can apply the formula. So for charging, what is the formula? I is equal to I into E, I into 1 minus E power minus T by tau. Now what is I? Capital I, you know, it is E by R. Okay. Now what is E by R? E by R has been given here. What is E? E is going to be the 100 volts. Okay. And what is R? R is 25. So you will get 4 amps. Okay. So current value has been obtained. Now what is T value? T value has been given twice the time constant. So twice the time constant means you put here as 2T. So 2T means this T and T will get cancelled. So you will have the value as I is equal to 4 into, you will have this equation, 4 into 1 minus E power minus 2. Or taking your calculator and calculating, you will have I is equal to 3.46. Okay. This is what is the value for current. That's what has been asked. What will be the current in the circuit? Okay. Now next, in the circuit shown, now see, they had given the circuit. In the circuit shown, 1 minute. One second. Just go through the second one. In the circuit shown, find the expression for the transient current and the initial rate of growth of transient current. Okay. Now, if you see here, they had asked you to find the expression for the transient current. They had given you the RL circuit. So resistance value is 5. Okay. And the inductance value is 3 Henry. Okay. So now you have to, the voltage value is also given. Voltage value is 100 into U of T. Okay. And I of 0 is also given. I of 0 is 6 amps. Okay. Now the procedure is, see, this is similar to the circuit. You can directly solve it by the final equation. Okay. Or you can solve it by writing stepwise equation. Okay. Now I had solved it here stepwise just to make you understand. But in this circuit, if you directly substitute also, you will get the same answers. Okay. Now, first, the procedure is, first you have to write the equation based on KVL. Now see here, equation based on KVL, we are writing it as 5 into I. So the current flowing here is I. Okay. So 5 into I plus 3 into di by dt. Di by dt is going to be the rate of change of current through the inductor. Okay. Is equal to U of t. 100 into U of t. Okay. Now what is 100 into U of t? 100 into U of t is the voltage source here. Okay. So this is the circuit under consideration and you have written the KVL equation. Right. Now, next what you will do, it has been given I of 0 is equal to 6 amps. It has been given. Now, first we have to, after writing KVL equation, this step 2, you have to take a Laplace transform of that. Okay. So, if you take a Laplace transform here, you will have 5 into I of s. Okay. We are taking Laplace transform for equation number 1. So, 5 into I of s plus 3 into, now this is the inductor. So inductor, you will normally have it as S into I of s minus I of 0. Now I of 0 has been given as 6 amps, so we will substitute here. Okay. And 100 into U of t. Taking Laplace for 100 into U of t, you will have 100 by S. Okay. So now rearrange this. I of s is taken outside. So I of s into 5 plus 3s. Okay. 5 plus 3s. 3 into 6. Okay, I of 0 is 6. So you will have it here as 18. Okay, is equal to 100 by S. Okay. See, now this is going to be minus 18. This is, here you have a negative sign. Now check the direction, what has been given here. The direction of the current here is opposite. Inductor current is opposite. Okay. But what is the circuit current? It is traveling in the other direction. So you have it as minus 18. Okay. So you put it as plus 18. Minus into minus will become plus 18 is equal to 100 by S. Okay. So now rearranging this, you will get I of S is equal to 100 by S minus 18. Okay. Now 100 by S minus 18. Next, what should you do? You have to rearrange and take Laplace. Okay. So 100 by S minus 18. So this will be I of S is equal to 100 minus 18S after taking LCM and bringing this 5 plus 3S down. Okay. So this will be 100 minus 18S by S into 5 plus 3S. Okay. Now, this is coming as a equation, right? So you have to solve it by partial fraction. So partial fraction, you put it as, I think you are aware of partial fractions, right? So in transients, everything you will be needing to solve by partial fractions. Okay. So A by S plus B by 3S plus 5. Okay. Now equate this minus 18S plus 100. Whatever is there, I had just put it here. Okay. Minus 8S plus 100 divided by S into 5 plus 3S. And whatever we had assumed here, A by S plus B by 3S plus 5. Okay, now put values for S and then you have to find out the value for A and B. Okay, now this equation, the numerator you consider, numerator will be considered because denominator is cancelled. So you will have minus 18S plus 100 is equal to A into 3S plus 5 plus BS. Okay, now putting S is equal to 0. What happens when S is equal to 0? This side, this will be 0. Minus 18 term will move off. It will be 0. Okay, and BS will also be 0. So you will find out the value of A. A value will be equal to 20. Okay. Now next you have to find out the value for B. Okay. So finding out the value for B means again put the value for S. Put S is equal to minus 5 by 3. Okay. And you put B value. You when solving this, substituting, put S is equal to minus 5 by 3, you get this equation. Okay. After solving this, you get B is equal to minus 78. Okay. Now we had got A value 20 and B value minus 78. Now substitute here. So this will be 20 by S minus 20 by S minus 78 by 3S plus 5. Okay. Now taking the next one is you have to take inverse Laplace. So for taking inverse Laplace, if it is of 1 by S plus A format, it will be very easy for you to write the formula. So this 78 is brought down by cancelling with a 3. Okay, just rearrangement of the equation, you will get it as 20 by S minus 26 by S plus 5 by 3. Okay, or I of t value will be equal to 20 minus 26 into e power minus 5 by 3, because you write 1 by S plus A is equal to e power minus at, right? So this is the equation for the current. Okay. Now they had also asked you to find the initial rate of growth. Okay. So initial rate of growth of I will be found out with the value of t is equal to 0. The small t value should be substituted as 0. Okay. So by substituting it, you will get the value of di by dt is 43.33, because when you substitute here, this will become e power 0. E power 0 will be equal to 1. So it will be minus 43.33. Di by dt will be equal to 43.33. Okay. This is how you find out the value of I of t. Okay. We will put one more problem. This is for RL discharging. Okay. After this RL discharging, I will check out your doubts before proceeding with RC. Okay. Now check here. Just go through this problem. In the circuit, switch S is in position 1. Okay, for a long time, and brought to position 2 at time t is equal to 0. Determine the circuit current. So it has been connected with position 1. Okay. After some time, the position of switch is changed from 1 to 2. Okay, now you check here, this problem is not same like the discharging, because in discharging, There is no voltage source connected, but here you have a voltage source connected. Okay, so you have to work out. Now how to work out? Same way you will be doing. You will first write the equation based on Kirchhoff's voltage law. You will take Laplace transform, solve by partial fraction. Step 3, solve by partial fraction. Step 1, write the equation based on KVL. Step 2, take a Laplace transform. Step 3, solve by partial fraction. Step 4, take inverse Laplace. This is the procedure. Okay. Now we will solve it out here. After closing the switch to position 2, you have to apply here. Okay. So what will be the thing? 5i plus 2 into di by dt. If inductance is there, means rate of change of current only. Okay. You cannot just put 2 into I. Okay. Is equal to 10. Okay. Now you have to take Laplace transform. Laplace transform phi I of s. Okay. This here phi I of s plus 2 into I of s minus I of 0 is equal to 10 by s. Okay. Now what is I of 0 plus? What is I of 0 plus? You tell me what is I of 0 plus. I will give you the chat. How to calculate I of 0 plus, you tell me. The chat is open, just post there. I will show you the circuit. What is I of 0 plus? 0 plus is calculated when the switch is in position 1. Okay. Now tell me what is the value for I of 0 plus. I am waiting for your answers. What is the value for I of 0 plus? No one is listening then? What is the value for I of 0 plus? 10? Only from one student I had got out of 221 students. Only Samyuta has answered me. What about others? What is the value of I of 0 plus? Okay, 10. How you are getting 10 is? How you are getting 10 is 50 by 5. 50 by 5 will be 10. Okay, so 50 by 5 we are getting it as 10. Next, we are going to substitute this value there and take a rearrange the equation and solve it by partial fractions. Okay, now see here the same way you will proceed. I of 0, 5 into I of s plus 2s into I of s is equal to 10s plus 20. I am substituting this 10 in the previous equation. See here, 5 into I of s plus 2 into s into I of s minus 10 is equal to 10s. Okay, now that minus 10 into 2 will be minus 20. That minus 20 is brought this side for plus 20. Okay, so now rearrange the equation, pull out I of s in common. Okay, I of s outside if you bring, you will have 2s plus 5 into I of s is equal to 10 plus 20s by s. Okay, next, by solving by partial fractions. Solving by partial fractions, you will split down the equation and write it as a by s plus b by 2s plus 5. Okay, so now the expression will be 20s plus 10. I hope this you understand, because partial fractions will be 20s plus 10 is equal to a into 2s plus 5 plus b into s. Okay, or put s is equal to 0. If you put s is equal to 0, you can find out the value for a. A will be equal to 2. Okay, or putting s is equal to minus 2.5, you will get b value, b is equal to 16. Okay, now substitute this value of a and b in the equation. So this will be 2 by s. Okay, I'm just substituting the value here. 2 by s plus 16 by 2s plus 5. Okay, now take inverse Laplace. Before that, this 2s coefficient, you remove it. I'm taking this 2s upside to the numerator. Okay, so 16 by 2 will be 8. Okay, and s plus 5 by 2 will be s plus 2.5, right? So taking inverse Laplace transform, 2 by s will be 2 plus 8 into e power minus 2.5 into t. Okay, this is the final value of the equation. Excuse me. Now this is the value for, this is the thing we have done for RL transients. Okay, now any doubt you have here, you just post me in the chat box. Otherwise, I will start up with RC. RL, any doubt is there? Post me in the chat box, or if any problem has to be repeated also, you tell me, I will repeat it, and then we will proceed for RC. Waiting 2 minutes, I'll wait fast. Or I can proceed, you tell me, such that I will start up with the RC transients. RL is clear? Any doubts in RL? See, in the last problem, they had given the circuit. In the circuit, they had asked you to, they told switch S is in position 1 for a long time and brought to position 2 at time t is equal to 0. So from position 1, it has been changed to position 2. So what is the thing? In position 1, the inductance has been in charging state. Okay, coming to position 2, the inductance should be discharging. It does not mean that if voltage is not there only, it will discharge. It is not like that. If voltage is there also, voltage source is present also, the inductor, if it is charged to maximum, it will start discharging. This is the thing. Okay. So what you will do, you will write the equation, KVL equation, when it is connected to position 2. So this will be 5 into I plus 2 di by dt is equal to 10. Okay. So this is the main equation. Now for this, you have to take a Laplace. So Laplace will be 5 into I of s plus 2 into, this is for inductor. Inductor should always have a minus current term, because we have to reduce the current, reduce the charge whichever has been charged in the inductor during the previous circuit. So you will write it as plus 2 into s into I of s minus I of 0 plus is equal to 10 by s. Okay. Next. So you know what is I of 0 plus? I of 0 plus is equal to 50 by 5. 50 by 5 because it is the same formula as E by R. Okay, what is the E value here? E value here is going to be 50. Okay, this is the E value 50 and resistance is 5. So 50 by 5 will be 10 amps. Okay, now substitute here 5 into I of s plus 2 s into I of s is equal to 10 by s plus 20. Okay, just rearranging the equation, you have got this. After this, you have to again rearrange such that you have to solve for partial fraction. So find out the value for I of s. I of s is equal to 10 plus 20s by s into 2s plus 5. Okay, so this can be written as a by s plus b by 2s plus 5. Clear? So partial fractions, solving by partial fractions, put different value for s and find out the value for a and b. Putting s is equal to 0, you get a is equal to 2, and putting s is equal to minus 2.5, you get b is equal to 16. Okay, so After taking Laplace transform, you have I of t is equal to 2 plus 8 into e power minus 2.5 into t. Okay, right. We will start up with the RC transients. Now, RC transients, wherever the inductance is there, you are going to place a capacitance. Okay, but the behavior will be different as compared to the inductance. Okay, now see here, RC transients, let us consider a circuit. Let us consider a circuit, RC series circuit with a voltage source E. Okay, and the switch S is connected here. This is the switch S. Okay, and the switch is assumed to be closed at t is equal to 0. So if the switch is closed at t is equal to 0, then this becomes a closed circuit, right? Now, as a capacitance is there, you have to consider for an initial charge. Okay, so let Q naught be the initial charge. See here, it has been written here. We've written here, let Q naught is equal to the initial charge on the capacitor. Okay, so the initial voltage. Now, when charge is there itself, you are worried about the voltage of it. Okay, now as far as the inductance is considered, it is related with the current. When it is coming for the capacitance, it is always related with the voltage. Now, what is the relation between the voltage and charge? Voltage is equal to Q by C. Okay, Q by capacitance. So, the initial voltage on the capacitor V naught is equal to Q naught by C. Okay, now apply after t seconds of closing the switch, applying KVL to the circuit. So a KVL is applied here for this circuit. Okay, so this will be IR. Okay, IR is the voltage across this resistance plus voltage across the capacitance. Voltage across this capacitance will be 1 by C into integral of minus infinity to infinity. So minus infinity to t, because we are closing at t at the instant t. Okay, minus infinity to t into I of dt is equal to E. Okay, E, because here we are connected a voltage source here. Okay, now this minus infinity to E, whatever we have written here, okay, this minus infinity to t will be splitted and written into 2. Okay, so we are writing it as minus infinity to 0 and 0 to t. So two terms we are splitting and writing, because we know the value we know the initial value, right? So that's why we are splitting it. So IR is written the same, plus 1 by C into integral of minus infinity to t is splitted out into minus infinity into 0 plus 0 to t. Okay, so it is splitted into 2. So minus infinity to 0 means I into dt. Okay, plus 1 by C into integral of 0 to t I into dt. Okay, so now substituting the value of the initial voltage. Okay, so minus infinity to 0, here we are going to substitute this V naught. So IR plus V naught, for this we are writing it as V naught. Okay, for this we are writing it as V naught plus plus 1 by C into the other expression has been written same way. The integral of C to t, integral of 0 to t I dt is equal to E. Okay, now what is the initial charge? Initial charge, we are assuming the capacitance is not charged anywhere, and we are going to put it as 0. Okay, only in this condition it will be 0. For discharging, you will put some value there. So here you have to put it as 0. So we are substituting V naught is equal to 0 in the equation. So if V naught is equal to 0, the equation reduces like this: IR plus 1 by C into integral of 0 to T I dt is equal to E. Okay. Now see, I'm going to take Laplace transform here. Okay. IR, when I take a Laplace transform, it will be R into I of S plus 1 by C integral of I dt. Integral means you will put it as 1 by S, right? So you will write it as 1 by C into I of S by S is equal to E by S. Okay. Now rearrange and solve this. I of S is equal to R plus 1 by CS is equal to E by S. Okay. I of S is equal to E by S into R plus 1 by SC, the last one. Okay. Now rearrange again. R, the coefficient of S, you pull it outside and you will get it as I of S is equal to E by R into S plus 1 by RC. Okay. So we have got now the IFS value. The next step, what we have to do is you have to take a inverse Laplace transform. So taking, finding out I of t is from I of s to find out I of t, you have to take a Laplace transform. Okay. So taking Laplace transform, I of t is equal to Laplace inverse of I of s. Initially you will take Laplace. Finally you have to take inverse Laplace. Okay. So this will be I of t is equal to E by R into E power minus T by RC. This is because from this equation, you are having it as 1 by S plus A format. 1 by S plus A means it will be written as E power minus AT. Okay. So this will be E power minus T by RC. Okay. Or putting different values of RC, you will get the value as 0.36 into E by R. Okay, 0.36 into E by R, or you will write it as 0.36 into I. Okay. So now what is the time constant here? Time constant here is RC. There in RL circuit, it will be L by R. Here it will be product of R into C. Okay. And it is represented by lambda. So you will write the equation itself like this: the current charging, will be I of t is equal to E of I into E power minus t by lambda. There you will be writing it as tau. Here you will write it as lambda. Okay. Clear? Now plotting the equation. If you plot the equation, you will get the response like this, moving down. Okay. This is opposite to that of the inductance, that you have to definitely remember. Okay. Inductance will be charging in the upward as a rise current. Okay. This will be decrease of current. Okay. Because in capacitance, the voltage starts to increase. So what will happen to the current? The current will be decreasing. Okay. Now coming to the voltage across the resistance and capacitance. So you know ER is equal to R into I, right? ER is nothing but the voltage across the resistor. So voltage across the resistor is given by R into I, or you can write it as E into E power minus T by tau. Okay. Now from the circuit, you can put it as ER plus EC is equal to capital E. Capital E is the voltage source, ER is the resistance, voltage across the resistance, and EC is the voltage across the capacitance. Okay. Now calculate the voltage across the capacitance. From this equation, you can write EC is equal to capital E minus ER, or this will be capital E into 1 minus E power minus T by lambda. Okay. This is the capacitance equation. Now moving forward, how does the graph comes for ER and EC? So ER and EC, you check here. The ER is like this, moving down. ER is moving down. ER is moving down. Okay, this is the voltage of resistance and capacitance, and the x-axis is the time. You call this as a time response graph. Okay, they will be in part A, they will be asking you to give the time response of the RC transients charging or RL transients discharging. So you have to be in a position to draw this graph. Okay, and capacitance, if you see, the voltage is increasing. So you will see that this is going to be increasing. Okay. This is how you proceed for RL transients charging. Okay. Next, we will move in for RL transients discharging. Okay. Now, sorry, RC transients discharging. Now check here in this circuit. So this is for RC transients discharging. So we are considering a circuit connected in series of resistor and capacitor, okay, with a voltage source E. A switch is connected, yes, which will be at position 1 for a long time, and then at t is equal to 0, the switch position is changed from position 1 to position 2. Okay, so what will happen? The capacitance will be charged by the voltage source when the switch was connected in position 1, and the capacitance will start to discharge when the switch is at position 2. Okay, now check here. We are now writing again the equation IR plus 1 by C into integral of minus infinity to T into IDT. So this minus infinity to T will be splitted now. Okay, it will be splitted and written as 1 by C into integral of like this minus 0. You'll be writing it like this, IR plus 1 by C into integral of minus infinity to 0, that is minus infinity to T interval is splitted into minus infinity and 0 and T. Okay, this is splitted into 2. Now you will put the value for the voltage of the capacitance. Okay, in the previous stage, the voltage of the capacitance was taken as 0 because it is considered in position 1 and there is no initial charges we had considered. But in discharging, we have to take into consideration of the first step. First step was charging. So you have to calculate the voltage. Let me assume the voltage is E. The voltage is E. Okay, so now substitute this value here for minus infinity to 0. It is substituted the value as E. Okay, so IR plus E plus 1 by C into integral of 0 to T I into dt. Okay, is equal to 0. Now what is the next step? Next step, you have to take a Laplace transform. Okay, now taking Laplace transform, it will be written as for IR, you will write it as I of S. Laplace is very, very important. Without knowing Laplace transform, you cannot attend any problems in transients. Transients is fully based on Laplace. Okay, I of S into R plus this E is taken to the other side of the equation like this. Okay, plus 1 by C integral of I of t I dt. You will write this equation as 1 by C into I of S by S. Okay, so this will be reduced as I of S is equal to R plus 1 by SC, that is equal to minus E by S. Okay, now again rearrange the equation, bring this entire term to the other side. So it will be 1 minute. So if you see here, it will be I of S is equal to minus E by S into R plus 1 by SC. Okay, or this will be minus E by R into S plus 1 by RC. Okay, or I of t is equal to Laplace inverse of I of S. So that's how you get I of t value. You have to take a Laplace inverse, right? So I of t is equal to L inverse of I of S. So this will be equal to minus E by R e power minus t by RC. Okay, now what is RC? RC is the time constant. You call it as lambda. So you put it here as I of t is equal to minus E into e power minus t by lambda. Okay, the current is called discharging current. Okay, so now how to draw the response? Check here. The response for discharging current will be like this. Same way, you can give some values for t. Small t is equal to, first put t is equal to lambda. Second step you put t is equal to 2 lambda. Third step you put t is equal to 3 lambda. T is equal to 4 lambda. So what will happen? The lambda will get cancelled. You will get it. You will get the value as e power minus 1, e power minus 2, e power minus 3, e power minus 4. Okay, so get the values for e power minus 1 from your calculator. Okay, so e power minus 1, plot that value here in the graph so that you can see you will be getting this type of graph. Clear? This is RC discharging. Okay, so now we have started up with the transients. Now you know the behavior of the circuit during the transients. What is transients? Transients is going to be a short period of time, uh, a very short period of time, right? So we will be considering with respect to the switch, when the switch is closed, when the switch is open, what is the response of the circuit? This is called as the transient response. So it can be a forced response or it can be a natural response, anything. It is possible, anything is possible, okay? So next you will be, we discussed what will be the behavior of the inductor and the capacitor during the transient conditions, okay? Next, RL transients. So we have, see, in transients we have DC transients and AC transients. DC transients is nothing but a circuit with a DC voltage source, and AC transients are present. AC transients will be present if the circuit is connected with the AC source. Okay, so transients is majorly classified into DC transients and AC transients. So we have started with the DC transients, clear? So in the DC transients, we have RL charging, discharging, RC charging, discharging, and RLC. Okay, now we had completed for RL and RC. Okay, next we will be going in for RC problem followed by RLC. Clear? Now till this, if you have any doubt, you can post, ma. The chat box is open. Any doubts you have means you please tell me. Any doubts you have means you please tell me so that I will explain it. Any doubts in RL charging, discharging, or RC charging and discharging? You please tell me. We can proceed. Are you clear with the transients now? The last unit consists of transients and resonance. Okay, the fifth unit is transients and resonance. We have started with transients. After completing DC and AC transients, we will be starting with resonance. By the time today, we will be posting the assignment 3. Okay, third assignment will be posted today. Please complete it off within the due date. Okay. Right, I think you are clear with the topic. Can we proceed with this problem? Okay, we'll continue this problem in the next class then. Just go through, this is the PDF which has been posted in the LMS. The same PDF only we are teaching. So please go through the PDF, okay? And post your assignments. Assignment 3, please submit it within the due date, okay? Any doubts here? RC transients, any doubts? Okay. If no doubts are there, then we will wind up. We will continue in tomorrow's class. Thank you.